In this chapter, we're going to look at rational expressions. In this lesson, we're going to solve word problems that require rational equations.
Hi everyone. So what we're going to be doing now is we're going to be looking at word problems that deal with rational expressions. Now, there are tons of different ones that we could use here, but what we do specifically in this course is we focus on distance, speed, time problems, because there's enough ways that we can ask those kinds of questions to kind of deal with the variety of equations that you're going to get. So we're okay kind of just sticking with that theme here. So there are three types of problems that you're going to get. We're going to look at questions where there's equal time, where we're asking for total time, and then we're going to give you the difference in the time. Okay, and this is an interesting little statement right here. Faster time plus wait time is equal to slower time. Now, right now, that might make total sense. You think about two people running a race, for example. The amount of time it takes the slower person to complete the race is the amount of time it takes the faster person to run the race, plus the amount of time they have to wait for the slower person. So the fast person gets there, they're done the race, and then they just basically got to stand there and wait until the slower person arrives here. Now, that probably makes sense right now, but we're going to see in a little while here that actually the temptation, and it's quite a strong temptation, is to want to put this extra time in the wrong spot. But we're going to take a quick look at that, and we're going to make sure that is clear. We can use the quadratic formula to factor equations that are more difficult, okay? Or you graph them on your calculator if you want. And just one last little thing here. Remember that distance is going to be speed times time, which means, and this is probably the more important piece of this, that means if you're going to look for time, that's going to be equal to distance divided by speed. And actually, this is the equation right here that we're going to probably end up using or taking advantage of more often than not here. You're going to see in a lot of questions, we structure things with a little table to kind of help us navigate the problem a little bit. In fact, you might even find later on, even if we don't provide the table, that you might build it on your own just to kind of make it easier to navigate those kind of problems there. So anyway, let's take a look at some examples. Okay, so for our first problem, we read that Melanie drove 404 kilometers from Edmonton to Banff in the same length of time. Okay, so the same time. So that's that first type of problem we were talking about here. Actually, this is a nice one to start off with here. So the same amount of time as it took Heidi to drive 364 kilometers from Edmonton to Jasper. Melanie drove 10 kilometers faster than Heidi. At what speed did each drive? Okay, so here we go. We know that Melanie drove 404 kilometers. That's what this chart is about here, just kind of structuring these numbers here. And Heidi drove 364 kilometers. Now, I don't know how fast either of them drove, but I do know that Melanie drove faster. So however fast Heidi drove, let's call that X, Melanie drove X plus 10 kilometers per hour faster. So we're just going to add here. Now, it's going to be tempting to do something a little funky with time here, but remember that time is distance divided by speed. And every time we do this, I want you to think about that. It's distance divided by speed. Well, how far did Melanie drive? She drove 404 kilometers. How fast did she go? X plus 10. There's my unknown. And in fact, there's my rational. Heidi, on the other hand, went 364 kilometers, and she was driving X kilometers an hour. So here we go. So the equation we can build here, because we know they did it in the same amount of time, we know that 404 over X plus 10 must be equal to 364 over X. Okay, so now we've got this nice little proportion. Okay, we got fraction equal to fraction here. So over on the side here, I might write that X can't be equal to 0 or negative 10. I see that from the denominators. But then I'm going to use cross multiplication to solve this one. And I will get 404 multiplied by X will equal, and actually it's very easy to distribute that 364 by that X plus 10. That'll be 364X plus 3,640. And remember, with the stipulation that X can't be equal to 0 or negative 10. I will subtract the 364 from both sides, and actually that works out pretty nice. That gets me just 40x is equal to 3,640. X can't equal 0 or negative 10. And then I'm going to divide. And when you divide, you are going to get 91 kilometers. And that's neither 0 nor negative 10. So that's good here. So what that means is Heidi drove. Whoops, did I spell it right? No, there's an I there. So Heidi drove 91 kilometers an hour. Whoops. Sorry, get that a little bigger there. There we go. Heidi drove 91 kilometers per hour. And Melanie drove, well, she drove 10 kilometers an hour more than that. So she drove 101 kilometers per hour. Okay, and there you go. Now, this next question says a trawler travels 4 times as fast as a tugboat. Okay, well, that's interesting. There we go. We're doing multiplication, 4 times as fast. The previous question, it was like an addition when we compared them. This one's going to be multiplication here. So a tugboat requires 14 hours more to travel 70 kilometers than a trawler. So if x represents the speed of the tugboat, then an equation that could represent the problem is, okay, well, let's set this up here. So we are going to work on distance, speed, time. And then we'll start with the trawler. Then we got the tug. Okay, so they're both going 70. It looks like they're both going to do the same standard distance here. We know that however fast the tugboat goes, you don't know what that is, the trawler goes 4 times as fast. So 4 multiplied by that. Not 4 plus, 4 multiplied by. And then my time is simply going to be 70 over 4x. Or in the case of the tugboat, 70 over x. Remember, it's time is distance divided by speed. Now, it says the tugboat requires 14 hours more. Now, the temptation is to do this. The temptation is to say, well, if it takes the tugboat 14 hours more, we better add 14 to it. But then you're misunderstanding the problem here. The tugboat takes 14 hours more. That number here, whatever the time is that the tugboat takes to get there, it's already 14 hours more than the other one. The trawler gets there fast. Okay, the trawler gets there quite fast, and so as a result, it has to wait 14 hours for the tugboat to get there. I do not have to add the time to the tugboat. The tugboat has already got that time there. I have to add that time to the trawler, because the trawler got there a lot quicker. It got there in way less time. So there's a 14-hour difference. And so I hope that makes sense. That can be a real problem for word problems of this nature here. Okay. So the time that it takes right here, the time that it takes the tugboat is going to be the time that it takes the trawler plus an additional 14 hours. Okay. It requires 14 hours more. There's your addition. Now, when you look at the ABCD, well, that isn't there. But all I got to do is subtract that term right there from both sides to get 70 over x, 70 over x minus 70 over 4x equals 14. And then you can see that it's going to be D. Okay, so now for this problem, we read that the speed of a plane is 5 times as great as the speed of a car. Okay. So right there, we know that the speed of the car, if we call that just x, we know that the speed of the plane must be 5 times as great as the speed of the car, so 5x. And then we've got that the car travels 3 hours longer than the plane to travel 315 kilometers. Okay, so we've got this 315 here. Okay, the 315. And now it says 3 hours longer. Now, over here in the time section, I know it's really tempting to want to throw in that 3 hours. But what that 3 hours does is it helps to equate the 2 times. Okay? So, for example, the plane takes how much time? Well, that doesn't answer the question if I say 3 hours less than the car. And if I say, how long did it take the car to go? And you say, well, 3 hours more than the plane. Well, that doesn't answer the question. That doesn't actually give me anything to work from here. So this is why we have to go back to that definition of time as being distance over speed. distance over speed. Now, one of the nice things here about the way this one is set up here is that I can actually simplify this a little bit. This 315 over 5x, that actually can become 63 over x. And I like that. That's a little bit nicer here. So now what I've got is I've got this 63 over x. This is the plane. And the 315 over x, and that's the car. Now, these two times are not equal to each other. There is a 3-hour difference to them. The car takes 3 hours longer than the plane to travel 315 kilometers. Now, that means that the time that the car takes is 3 hours longer than the time that the plane takes. So in order to make them equal, what I need to do is I need to add the extra time to the plane. So this is basically, think about it like this. This is the flight. 63 over x is the flight. And this is the amount of time that you wait for the car to drive. You always add that extra time to the faster one because that's going to be the wait time here. Okay, well now to solve this, this is actually not too bad. What I'm going to do is I'm going to bring the x terms together. And the reason why I want to do that in this particular case is because if I do that, if I do 3 is equal to 315 minus 63 over x, the reason I like that is because I've already got common denominators there. So I don't need to worry about finding a common denominator. It's already been done. And then what I get here is that 3 is going to equal 315 minus 63 is going to be 252 over x. I've basically got a proportion here because 3 can be written as a fraction, so I'm going to cross multiply. So 3x is equal to 1 times 252, which is just 252. And when I divide that by 3, I get 84. So now find the speed of both. Okay, well, what I do here is I know that the car travels 84 kilometers per hour. And the plane, well, the plane is going to travel 5 times that. And 5 times 84 will be 420. Okay, and I've got just a little bit in the way here, kilometers per hour. Okay, and there we go. Okay, so this question says, Kate and Maddie both drove for 30 kilometers each. Okay, so 30 kilometers each. We're going to fill that in our chart, 30 kilometers. And then Kate drove 12 kilometers an hour faster than Maddie. Okay, so we're going to let Maddie be x, and that means Kate would be x plus 12. Now, we could have done it with Kate being x, and then Maddie would have been x minus 12. It's just a little bit easier to work with addition and subtraction here. And then we see that Kate arrives 5 minutes sooner than Maddie. Now, remember, that's a comparative statement. That doesn't give me any information about how long it took Kate to travel or how long it took Maddie to travel. That's just a comparison between the two. So here in our third column, what we want is the amount of time it took Kate to travel. And so that's when we do our distance over time. Sorry, distance over speed to get time. And for Maddie, it's distance over speed to get her time. And then here we go. So we've got 30 over x, and we've got 30 over x plus 12. We want to come up with a different, the relationship between them. Now, they're not the same. They are going to be different. In fact, there's a difference of 5 minutes between them. So that actually implies a subtraction here. So when we take a quick look at this, there are a couple of ways that we could set this up here. Now, bear in mind here, Maddie is going slower. So this is going to be the larger of the two. This is going to be the smaller. So actually, one way that I could do this, just by default, I could put a big old subtraction here, and that is going to be equal to, and we want to be really careful about this one because this has got a sneaky little issue with it. It's 12 kilometers per hour, and yet this over here is 5 minutes. So we got to be careful that we're in the same units here because our speed is in hours. We probably want our time difference between them to be in hours as well. So instead of writing 5 minutes, we're going to write 1/12 of an hour because 5 minutes is 1/12 of an hour, right? 5 over 60 is going to reduce to 1/12. And so there we go. The difference between them is 1/12 of an hour. Now we are going to multiply by that common denominator here, which in this case is going to be x plus 12, oops, and then 12. With the stipulation, and actually I'm going to have to erase that a little bit over here, with the stipulation that x cannot be 0 or negative 12. And actually that makes perfect sense. It doesn't make sense for Maddie to be standing still, and it doesn't make sense for her to be going backwards 12 kilometers an hour. When we multiply that through, and now we're going to take advantage, we're going to move through this just a little bit quicker. When I multiply that first term right here by x plus 12, 12, the x will cancel, so we're left with 30 multiplied by x plus 12 times 12 minus, and then we're going to have the x plus 12s canceling, so 30 multiplied by x multiplied by 12 is equal to, now over here, the 12 will cancel, so I'm left with x times x plus 12. Sorry, x plus 12. X plus 12, where x cannot equal 0 or negative 12. Now I multiply this all out here. So to start off with, we are going to get, we're going to get 30 times x times 12 here. So it's going to be 360x plus, then I'm going to get 30 times 12 times 12, which will be 4,320 minus, 360x. So I like that because without even doing the rest of the question here, I can see that those are going to cancel, which is wonderful. And then on the right-hand side, I'm going to get x squared plus 12x. Okay, now I'm going to bring over that 4,320. Oh, and remember, x can't equal 0 or negative 12. Same thing here. X can't equal 0 or negative 12. Still don't know what the final answer is going to be, so how that restriction affects it. Okay. Well, you might look at this. You might look at this and fight with this a little bit before you figure out what the factoring is. But it actually doesn't take too long here. You know that there's going to be like a multiple of 10 somewhere in there because of that 4,320. So you might guess certain numbers here, and it turns out the numbers that we're looking for are 72 and 60. X can't equal 0 or negative 12, and this tells us that x is going to equal to negative 72, which doesn't really make much sense, and then positive 60. And there we go here, okay? So we can write here that Maddie travels 60 kilometers per hour, and Kate travels 72 kilometers per hour when we add 12 to that. And isn't that interesting that that value that we rejected was the negative of that? What if that shows up a lot like that? And so there you go. Here's an example of, this is a really good kind of standard word problem in this section. Nice level of difficulty here. Bit of work involved, kind of got to interpret that answer. Really, really good. Okay, so our question here says, Mia and Liam travel 264 kilometers by car from Calgary to Edmonton to watch a football game. On the way to the game, Mia drove. On the return trip, Liam drove 10 kilometers an hour faster. And by doing so, he saved 0.3 hours of traveling time. So the partially computed table shows us the information. There we go. So notice what they've done is we've plugged X in for Liam. That forces us to say that Mia here drove X minus 10. We've up to this point here, we've been kind of avoiding the subtraction there. This question is just forcing that to come up to the front. But the time is still going to be done the same way. We're going to go distance. Whoops. Sorry, I don't know why I threw a 3 in there. We're going to do distance, which will be 264 over x minus 10. And then Liam will be 264 over x. And then the question is, which of the following equations could be used here? Well, okay, so we've got 264 over x minus 10, and we've got 264 over x. Now, the faster person, okay, the faster person is going to require less time. So here's the faster person. Liam is the faster person here. Me is the slower person. I was going to say smaller. Okay, that's not what I meant. I meant slower. Okay. So in order to make these two times equal, what I have to do is add that wait time to Liam's time. So this is his travel time, and then this is his wait time, and that's equivalent to me as travel time here. And when you look at our graphs here, what have we got here? Well, I don't. Oh, I do actually. Sir, there we do. I do see it right there. It's B. And there we go. Okay, so that was a little bit more straightforward than I was expecting, actually. Okay, now normally I've been breaking these up question to question here, but this question right here kind of has another part here. It says, using your calculator, graphic calculator, find Liam's speed to the nearest tenth. Okay, so this is a little awkward. I don't actually have the ability to nicely do that, so I'm just going to explain what I would do here. In this particular case here, what I would do is go to my graphing calculator and go to Y1, and I would enter in 264, okay, divided by bracket X minus 10. Then I would subtract. I'd bring everything over to one side, minus 0.3, then minus 264 divided by X. Because when I do that, that equation would be set equal to 0. And so that now, after I graph this, okay, after I graph, I'm going to be looking for x-intercepts. Now you're probably going to have to extend your window here because you're probably not going to see it unless you go quite a ways to the right. And in fact, your window settings, your x here should probably be something along the order of 0 up to, I don't know, let's say 150, going up by, let's say, tens. For the y, the window settings, vertical window settings, you actually don't need to do more than -10 to 10, going up by ones. The reason for that is I really just want to focus on the x-axis. I just need to make sure the x-axis is in the middle so I can see it. And then what we're going to do here is we are going to use, if you go into the menu where you can do calculations on the graph, so that would be the second, if you're using a Texas Instruments, the TI, the second trace calc menu, we're going to use, I believe it's number 2, the 0 function. And when all said and done, you should be getting 98.9 kilometers per hour. Sorry that I couldn't go through and show you that in a little bit a nicer way on the graphing calculator. Okay, and now finally here, when there is no wind, a runner is able to run 10,000 meters at an average speed of x meters per second. And when he runs with a tailwind, his average speed increases to by 0.05 meters per second, and it takes him 15 seconds less to run 10,000 meters. So the equation that shows the relationship is given below here. So when there is no wind, the runner's average speed to the nearest hundred of this. Basically, we just want to figure out what x is. Okay, so this question here is essentially setting you up to be done on the calculator. So, and we'd mentioned this before here, but what I would do here is in Y1, I would probably enter 10,000 divided by x minus 10,000 divided by, now that in order to get this to work out properly, you want to put parentheses around that denominator there. And then what I would do is I would bring over that 15, minus 15. So now what I'm looking for are the zeros of the function. Okay. Now we're talking about meters per second. This is somebody's running, so it actually can't be all that big. So I would make my window settings here, x from 0 to, let's say, 20, okay, going up by ones. And for my y, I'm looking for the x-intercept here, so I can just leave it as -10, 10, 1. As long as I've got that x-axis in the center there, I'm good. And so then once you graph it, I'm going to press second trace. This is on my TI-84, and I'm going to use 2, which is, again, is the 0 operation here. And after I do that, you should find, okay, now you're going to have to pick a left bound and a right bound. And your calculator is going to draw little vertical boundaries here with the little triangles there. You got to make sure that your x-intercept shows up in between those two boundaries there. Once you do that, press enter to get past the guess. And in this case, you should get 5.75 meters. So this question here really should just be an opportunity for you to practice being able to do that on the calculator.